Hello students, hello viewers. Welcome to Senior College Mathematics. Topic of discussion is indices. If you are in senior college, you are preparing for WAEC, for NECO, for GCE, for NAPTEP, for JAMB, or any other external or entrance examinations into high school, this lesson is for you. Lesson 9, Exponential or Indiscale Equations Part 3. Lesson 9 is continuation of Lesson 7 and 8. Examples: solve for the unknown letter in each of the following. For updates, follow Voice of Peter Course via YouTube at Peter Course Simplified Maths. To do that, subscribe to this channel, like this video, share the video to your friends, your colleagues, your classmates, your students. You can also follow Voice of Peter Course via Facebook, Instagram at Peter Course Simplified Maths. For questions and inquiries, use the comment section. We attend to them. Example 76. We have two pair of exponential equation, 3 power y plus s equal to 9 power y plus s and 2 power s minus y equal to 8 power s minus 3. So looking at the first equation, the bases 3 and 9. The common base there is 3. You can express 9 as base 3. That is 2 square. Looking at the second equation, base 2 and 8. The common or lowest base is 8. Sorry, is 2. Is 2. So you express 8 as 2 cube. As 2 cube. So if we expand this power, you have 2y plus 2s. If you expand this power, you have 3s minus 9. That is 3 times s. 3s. 3 times minus 3 is minus 9. So we have equal bases from both equations. So if you equate the bases, you have the powers left. You equate 3 to 3. You have y plus s equal to 2y plus 2s. If you equate 2 to 2, we are left with the powers s minus y equal to 3s minus 9. Okay. Looking at the system of equation, clearly we will see that they are simultaneous equations because you have two unknown variables, and in that group of equations you always rearrange such that you have the unknown letters on one side and the constant on the other side. So because of the way this first equation is, we are going to transfer y plus s to the right hand side, and we have 0 left in the other side. Okay, so we have 2s. Follow the order of the letters. You have 2s first. If you transfer plus s to the right hand side, what you have is minus s followed by plus 2y. If you transfer plus y, it becomes minus y. So you have 0 left after moving out y plus s. Then for the other equation, we're going to transfer s minus y to the right hand side and transfer minus 9 to the left hand side. So we're going to have 3s here. If you transfer plus s, it becomes minus s. You transfer minus y, it becomes plus y. And you transfer minus 9 to the left hand side, you have plus 9. So clearly you have s plus y equal to 0, which you can call equation 1. That is because 2s minus s is s. 2y minus y is plus y. For the other side, you have 3s minus s is 2s plus y equal to 9. That is equation 2. So let's solve by elimination method. So you have the two equations here. The voice of Pythagoras want to eliminate variable y because it has the same coefficients in both equations. That is the rule of elimination. The variable you want to eliminate must have the same coefficient in both equations. Then secondly, you have the option of adding or subtracting. You subtract when the signs are the same. That is plus y now. Then you add when the signs are opposite. But for this, we are going to subtract. So this s also means 1s. So 1s minus 2s. 1 minus 2 is minus 1. So 1s minus 2s is minus 1s, written in this form. Then plus y minus plus y simply means plus y minus y. That is 0. Then you have 0 minus 9. This is minus by using now. 0 minus 9 is minus 9. So you have minus s equal to minus 9. To get s, multiply through by minus 1. I'm looking for s, not minus s. So s is equal to 9. To get y, you substitute the value of s equal to 9 into any of the equation. So let's take equation 1. That is s plus y equal to 0. Where you are seeing s, you put 9. That is 9 plus y equal to 0. So you have to transfer 9 for y to stand alone. And 9 there is positive. When you transfer it to the right hand side, it becomes negative. So you have y equal to 0 minus 9. And y is equal to minus 9. Therefore, s is equal to 9. Y is equal to minus 9. If you do a check now, you will find out that your results are correct. Example 77. You have 4 to the power of s plus 1 minus 9 bracket close 2 power s, that bracket open, 2 power s bracket close equal to minus 2. Okay, looking at this equation carefully, we have 2 power s here. 2 power s can also be obtained from here, but we cannot get it from here. That means you cannot divide through by 2 power s. So let's try and get 2 power s from the first term. Now the first term is 4s, is 4 power s plus 1. Now think of it this way, that you have 4 to the power of s multiply by 4 to the power of 1. Okay, you know, if you simplify this by the law of indices, you are going to have this expression here. Can you see that? So we need to reverse this expression to the form we have here. That is this. So you have 4 power s times 4 power 1. Then minus 9 bracket open, 2 power s bracket close equal to minus 2. Since we are targeting 2 power s, we can express 4. This 4 that carries s in base 2, that is 2 power 2 now. 2 power 2 then times s, you have 2 power 2s multiplied by this, and the other terms follow. Okay, so by power law, you can factor out 2 from this place. for us to have 2 power s as we have it here. So you have 2 power s all square. 4 power 1 is 4, then minus 9 bracket open, 2 power s bracket close equal to minus 2s. The stage we are now, we cannot get s directly. What we do is that this term that contain s, you let it equal to any other letter. So let's say h. So we replace 2 power s by h. If you put h in this place, because of the square, you are going to have h squared times 4. If you put h here, you have 9h equal to minus 2. So the power of 2 clearly shows that we have a quadratic equation, and in that equation the right hand side is always 0. So you have to transfer minus 2 inside or to the left hand side, it becomes positive. So you have h squared times 4, that is 4h squared minus 9h plus 2 equal to 0. So we want to solve it by the method of factorization. In doing that, we have to compare the resulting equation with the general quadratic equation of as squared plus bs plus c. So we are taking s squared as h squared now, so that we have agreement between the variables. So if you compare it like that, you will see that a is equal to 4. You can see the way a is attached to s squared, that is why 4 is attached to h squared. So a is 4, then b is minus 9, and c is 2. By the method of factorization, when a is not equal to 1, you have to get ac. So ac means a times c, that is 4 times 2, and that is 8. So you look for 2, listen now, you look for 2 factors of ac, that is 2 factors of 8. When you add them, you get minus 9, and when you multiply them, you get 8. From the pairs of factors of 8, that is 1 times 8, 2 times 4, we can only see possibility with 1 and 8. For you to get minus 9, when you add 1 and 8, it must be minus 1 minus 8, or minus 8 minus 1. So that is the possible factors. Minus 8 minus 1. So let's continue. So we have the equation here, and our possible factors are minus 8 minus 1. What we do is that we replace or display the middle term using the factors in terms of h. That is minus 8 minus 1. In terms of h, we replace minus 9h. So you have 4h squared minus 8h minus h plus 2 equal to 0. The purpose is to have 4 terms that can be grouped to each group. So the first group, you have 4h squared minus 8h plus the second group minus h plus 2. I advise that you should always separate the two groups with a plus sign. That is why I'm taking minus h and plus 2 as one group. Look at the first group now. 4h squared minus 8h. 4h is common. So the common term that you factored out, you use to divide through. So if you divide 4h squared by 4h, you are left with h. You divide 8h by 4h, you are left with 2. With 2 from the first, that is for the first group now. From the second group, you can factor out minus 1 because only minus 1 is common. When you do that, you divide minus h by minus 1, you have plus h. Divide plus 2 by minus 1, you have minus 2 equal to 0. So at this stage, you can see that h minus 2 is common. When you factor it out from the first group, you have 4h. From the second group, you have minus 1, which will form the other bracket, and you equate it to 0. So you equate each bracket to 0. That is h minus 2 equal to 0, or 4h minus 1 equal to 0. If you transfer the constants, minus 2 and minus 1, you have h equal to 2 or 4h equal to 1. For the second side, you divide both sides by 4 now. So you have h equal to 2 or 1 over 4. But you were not asked to find h, but s. We only brought h in to enable us get s. So recall that 2 power s is equal to h. So when h is 2, you equate 2 power s equal to 2. Clearly the power here is 1. So if you equate the bases, you have s equal to 1. Then when h is equal to 1 over 4, you equate 2 power s equal to 1 over 4. You have to express 4 as 2 square, and when you take 2 square up, the power become negative for us to equate the two bases, and you have s equal to minus 2. Therefore, s is equal to 1 or minus 2. So this is how we solve this type of exponential equations. End of lesson 9 and the last lesson in this series of teaching. Thanks for watching and learning. Don't forget, watch out for more from the voice of Pittacus. Lastly, if you are not safe, your life will be in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, I tell you, big congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take care of yourself, study your books, stay out of trouble, do the needful at all times, flee every appearance of evil, don't defraud others to make money, use your hands and your brains to work, and the Lord will bless you. Goodbye.